Okay, the purpose of this video is to give a little background information on how a commercial gas furnace works, so we can have further discussions in other videos. For the most part, it's similar to your home furnace. If we look at the cross-section of a furnace here, you see that coming up on the top is the supply air, which is what feeds the heat to each of the rooms in your house. Typically at the bottom is going to be some kind of squirrel cage blower that blows air up. And then here, somewhere in the midpoint, is going to be the flames. And in here will be a heat exchanger so that this warms it up. And then the return air is coming back from the rooms, the registers that are usually low on the walls. And it just circulates air around. Then the air comes in through the return air, gets blown up through the flames, through the heat exchanger, and then back into the room as warmed air through the supply air ducting system. There's typically a temperature rise here of about 50 to 70 degrees Fahrenheit, and just for purposes of discussion, we could say that the room temperature or the supply air is going to be about 70, and the return air will probably be a little bit cooler, probably about 60 degrees. So you're going to have a significant rise in temperature here between 110 and 130 degrees, so it'll obviously warm up the room pretty quick. That's how most home furnaces work. If we kind of slide this away, we actually have a little bit more to a commercial furnace because we're required to bring in fresh air or outside air and mix that in when there's people in the building. So what we actually do is add on to the side here a mixing box, and it's just a simple steel box that has the return air still coming in off the side, but then we bring in outside air. In this case it comes from the roof, and this comes back from the rooms just like the home furnace. But then inside of here is a variety of baffles and some filters, so you filter the air and we create some kind of turbulence in here so it all mixes together. So what comes in here is a combination of the outside and return air. So for example, if we had return air like before of 60 degrees, perhaps our outside air is 30 degrees, we want to mix those two together and then warm it, and out it goes the supplied air. To do that, there's little dampers in here, in each one of these. And these are linked together with a little linkage so that if, for example, this one's completely shut, this one would be completely open. If it's 50-50, the ratio would be always so that if one is 30%, then it would be 70%. They're locked together, and then this little linkage comes down here to a motor, and that motor turns it so we can have anywhere from 100% return air to 100% outside air. Typically in heating season, we wouldn't want more than we have to have for outside air. It would be the other way around, of course, in the summertime. So what we would typically have here is a small percentage of outside air. Let's say we want 20% outside air, and we want 80% return air. You have to always add up to 100%. That's going to give us roughly, if you do the math and the algebra on this, could be about 53 degrees or so of a mixed air that's going to be coming in here. Okay, so it's slightly cooler than the return air, but it has a 20% outside air content. And then that will be boosted up by 50 to 70 degrees, and out it goes at 103 to 123 degree temperature. So that's kind of the basic ducting system of the commercial furnace. The other thing that you don't see here is a relief damper or a relief ducting system. So out here, also just going to the outside air, is a damper system. And if we're bringing in outside air, the building pressure is going to increase. So that air has to go someplace. So whatever air is coming in here from outside needs to go back outside somewhere else. So elsewhere in the building, there's going to be a shaft here that opens, and then the pressure of the building just causes that air to discharge outside. Now the other area that's interesting to a commercial furnace is that just as we can modulate or we can mix this air that's coming back from the room and from the outdoors, we also can modulate the flame or the amount of heat that's being added to the supply air. So instead of saying it's always going to be, let's just say it's going to be 50 degrees for ease of computation here. Instead of saying it's always going to be a 50 degree rise, we can say that that flame is going to go from 0 to 100%, and therefore it's going to go from a 0 degree rise to a 50 degree rise. and anywhere in between. That's the modulation, so that if we don't necessarily want to have 103 degree discharge temperature, we can bring that down somewhat and modulate that, both for energy efficiency purposes and for, as you'll see here in a little bit, for makeup air purposes. So that's an important part here too, is that flame modulation. You can do this in two different ways, as you'll see here shortly, but one way is to have a discharge temperature sensor here, right in the discharge air, right as it's coming out of the furnace. And that's just a temperature sensor, so that we can have a knob on the side of the furnace. It's going to be calibrated and set to whatever temperature you want. Let's say you're going to be anywhere from 50 to 90 degrees, and we want to set it maybe at 60, which says that we're going to hold this discharge air here at 60 degrees. Therefore, if we're having air coming in at 53, we only have to raise it 7 degrees to get it up there. So this is going to modulate this thing way back, have a very tiny flame. Sometimes it can't get quite that small. The turndown ratio determines that, and typically that's going to be a 1 to 30 turn down. In our case, we only have a 1 to 3 because we have a gas furnace system, so you really can't get down that low sometimes, so it'll end up just turning on and off. But it will still keep this temperature right at whatever the set point is for the discharge air. Okay, now let's take a look at some of the major components of the thermostat. It's very similar to your home thermostat, but it has a few extra little features to it. It's going to have a set point temperature, and that's going to be where you want the temperature. So there's going to be a knob on here. In this case it's digital, but the same concept. You'd be able to say, I want it, at 70 degrees is what I want the room temperature to be set at. That's the set point temperature. The set back is going to be whatever it is that you want it to go down to at nighttime when we're not using the space. And that would be, perhaps 55 degrees. It's just that simple from a user standpoint, but actually the thing sends out a couple of different signals. When you have a room temperature that falls below the set point by a degree, then it goes into first stage heat, which is just typically called heat 1. Heat 1 says, okay, we only need to raise it up a little tiny bit, so we don't necessarily need to have this flame on 100% and have this big influx of extremely hot air and then have it shut off all of a sudden. That would be, it would overshoot to 70 degrees, and it would feel kind of like someone who regulates the heat in their car by turning it full on and then full off, full on, full off. What this would do is say, okay, if we've dropped a couple of degrees, let's have this flame only be a proportional amount to what it is that we have to raise the temperature. If we only have to go up a couple, 3 degrees, the flame could be a fraction of the 100%. If for some reason we're falling behind and we get down, in this case, to 5 degrees below the heat 1 setting, then stage 2 kicks in, which is called heat 2 from a thermostat standpoint. And that difference there is just called the second stage heat offset. In this case it's 5 degrees, so 65 degrees is when that would kick in. Heat 2 says, okay, we're falling behind, forget about proportional flame, let's just turn the flame up to 100%, and we're going to crank it all the way up until we get to the set point. And that's just a way to recover. So for example, if a bunch of doors open up, or it gets really cold outside, something causes it to drop temperature significantly 5 degrees below the set point, then we just turn on the full flame until we get up to where we want to be. So that's heat 2. Normally you just be in heat 1 because that's enough to make up the small difference, because it's going to come on every time it drops more than a degree. There's also a setting here called occupied, and this confuses people because occupied can mean many different things. It's probably better just to view that setting as the same as like on your car when you have a fresh air versus recirculate. The occupied means that people are in the space, and therefore by law we have to bring in fresh air. We can't just have 100% return air going around and around. Even though it is filtered, we still have to bring in some outside air. And that's determined by law. There's going to be some type of formula, depending on if people are working or sitting or doing what, of how many cubic feet per person you have to have of air exchange every minute. And that's going to determine what this ratio here is going to be, or what this percentage is going to be. So for example, if it was 20% outside air would be the calculation for our occupancy, then whenever we're in occupied mode, we would have to have 20% outside air, 80% return air. If we were in unoccupied mode, then we would just keep this outside air damper completely sealed off, and have 100% return air for energy savings purposes. There's no sense to bring in outside air at that point. The outside air obviously consumes more energy because you have to raise it up that additional temperature if it's cold outside. Or if it's warm outside, conversely, when we get to cooling mode, you'll see then it's just more to cool. So this is the occupied or the fresh air setting. It's on the thermostat. Heat 1, heat 2, and the set point are the major features that we're concerned about. Okay, now normally that would be about it. However, what I've really described over here, these different modes here, is really just what we call heating mode. And that is that we need to add heat to the space. The temperature set point is at 70, and if it falls below that, we need to add heat. In a home furnace, once you hit the 70 set point, it just shuts off. In unoccupied mode, that's the case here too. We just shut it off because we're done heating. However, in a commercial system, just like if you've noticed in an office or in a store, the air runs continuously, even if there's not heat coming in. You may not have noticed that part, but that's the case. So that's called a makeup air mode. So there's another mode called makeup air, and in bigger systems, it's actually a separate system from the heating plant. There would be a heating furnace and then a makeup air handling system, and all that does is circulates fresh air and filtered air around and around, regardless if you're heating or not. So in unoccupied mode, we just shut off because there's no one there. We don't need to have fresh air. In occupied mode, when heating mode is no longer required because we've hit the set point, then we switch over into makeup air mode. And makeup air mode is the part that confuses people, I think, a little bit. But all that does is it keeps the blower going, and it keeps this ratio still the same, whatever this ratio needs to be to meet the law in terms of minimum air. And by the way, this is controlled typically by a small knob right here on the motor, and it's called minimum outside air percentage, and it's set like to 20% in this case. What we're going to do is continue to circulate air, but if you notice, if the room is at 70 degrees and we're bringing in 53-degree air with no flame, it's going to cool that space off. In fact, it's going to feel a little bit chilly, particularly if it gets really cold outside, or if we have a higher outside air percentage, then it's going to feel like there's cold air blasting down on people, and we don't want to have that. So that's where the modulation really comes in. We need to add a little bit of heat content to that so that we temper the air. And this discharge air sensor up here is what controls that during makeup air mode. So let's say we want to have it at 60 degrees. So it's coming in a little bit cool, but not icy cold. So what we want to do is maintain this discharge air at 60 degrees while we're in makeup mode, and the air coming in is only 53. Therefore, we only have to have a 7-degree rise. So this modulates way back. It just adds a little tiny bit of heat as it continues to pump in fresh air. It will continue to do that until, over here, the set point is no longer satisfied. We drop down to 69 degrees, 1 degree below the set point, and now we switch from makeup air mode into heating mode and add heat content. Heat 1 typically, because it won't fall more than a degree or two, again, unless there's some outside doors or some big heat loss taking place. And then it goes back into makeup air mode, so it switches back and forth. And then lastly, there's a couple of other modes. The makeup air mode here was the discharge air being modulated by the flame, the gas. And the heating mode was stage 1 or stage 2, and then we have occupied or unoccupied. I guess that's not really technically part of heating mode. Occupied or unoccupied for both of these, although unoccupied doesn't really make sense for makeup air because there's no reason to bring outside air in. However, there's a couple other modes that are typically used. Over here in heating mode, there's warm up, which says at the beginning of the day when we want to go from the set point way down here all the way up to here, I don't care if we're in occupied or unoccupied mode, because we just need to warm up the space as fast as possible, and bringing in outside air doesn't make sense when you're trying to warm up the space from 55 to 70, because even though it may be set for occupied, realistically it's going to be set before anybody arrives, or at least a little bit before, so we want to get up in temperature really, really quick. So warm up is just going to say close the outside air damper no matter what, even if we're in occupied mode, and turn the flames on to 100%. Don't try to modulate it, and just put as much heat content into the space as possible until you reach the 70 degrees. Okay, now let's walk through what the settings and actual temperature would look like throughout a normal day, where we have perhaps at the beginning of the day or overnight, we have a setback of 55 degrees. So here we are, maybe starting at 8 a.m. We want to start things up for the day. So at that point, we want to bring it up to 70 degrees. So the blue is going to be what our thermostat is set for our desired temperature. So it's going to go way up like this. And we're going to put that into warm-up mode, which means, of course, just bring in as much heat content as fast as possible. Don't worry about outside air or anything of that nature. Okay, and then we're going to say hold it at 70 degrees throughout the day, like that. And at some point, perhaps, I don't know, 5 p.m. or so, we're going to bring it back down again. So that's really just all there is to it from a thermostat standpoint. And the mode it's going to be in out here is occupied. And that's a bit of a misnomer. Again, I don't know if I like that word too much. It's really going to be in fresh air mode or in outside air mode, which means there's going to be occupied. There's people here, but we need to bring in fresh air is really what the concept is there. Okay? Now, with the orange, let's take a look and see what actually happens. At 8 a.m., we go into warm-up mode, and it's going to bring up the temperature just as fast as possible, so it may take it about, half an hour or so. So it's going to go up like this to 70 degrees, and then it's going to start holding it, okay? So that's the warm-up mode, which will now be done at that point. We go into, at that point, we're going to go into make-up air mode, slash make-up slash heat mode, going back and forth as needed. So as it hits 70 degrees, it'll just go into makeup mode, which means that we're just going to turn on the outside air, so we have a ratio of outside air and return air mixed together, and that's going to be pumped through the room around and around, with the only heat content being added is just enough to bring that up so that the supply air temperature is going to be probably about 65, I think is what we said before. So this is going to be our supply air during makeup air mode. So it's going to be a little bit lower, which is going to cause then this to start dropping. Okay? And this is going to drop not only because we're bringing in cooler air, but naturally the room itself is losing heat from windows, doors, outside walls, all that kind of stuff. So it's going to continue to drop down here. However, because our set point is at 70, it's really not going to fall down that far. It's only going to drop down 1 degree, 69 degrees, because we have a plus or minus 1 degree differential, which says let it drop a full degree, and at that point we need to turn the heat on. So it's going to switch. In this case, it's in just makeup air mode, and then as soon as it hits the 69 degree point, it's going to turn heat 1 on. And then it's going, so this won't actually occur. Then it'll come back up. This is kind of exaggerated here in terms of the timeline. Back up to 70, and then switch back to makeup air. And then, of course, it drops back down, and then goes back up. So it just goes back and forth between makeup air and heat 1 throughout the day. And that's just a 1 degree change right there. Okay? If it overshoots a little bit, that's possible. It could be as much as 1 degree on each side. Okay? Goes back and forth. The only thing that's going to interrupt that is if something causes a great deal of heat loss to where it drops down to 69, and even though we're in heat 1 mode, so let's say right now we're in heat 1 mode, is bringing it back up, but it doesn't get there, it just keeps on going down because there's a couple of doors open, so now we drop to 68, 67, and even though heat 1 is on, it just keeps dropping. What's going to happen at that point is eventually we're going to hit this offset, stage 2 offset at 65 degrees, because remember that was negative 5 degrees, and we're going to hit the 65 point, and then we're going to turn on heat 2, which is the full dragon mode, and it's going to take this up to 70, but it's going to do it much quicker because we're going to have the full flame on, and we're not going to try to do it in a gradual kind of pleasant way. We're just going to get it warm in there just as fast as possible. So that would be the H2. And then we would continue with this little seesaw thing here, going on with H1 versus the warm-up, or I'm sorry, the makeup air. Okay? And that's really all there is to it. At the end of the day, we come out here and it just falls off on its own. We just keep the furnace off, and it's going to take it a good long time to drop off because at this point there is no makeup air. We would only have the heat mode on, but obviously since the temperature is now going to be set at 55, it can drop a full 15 degrees, and I can do that gradually because we're not trying to pump fresh air through the building at that time.